Welcome back to the next class, my dear students. Hope in the previous class what we just discussed is, we just discussed some of the concepts which was exactly related to that of the total internal reflection, as well as even we discussed the concept of how the ray of light is going to undergo the refraction, and when the ray of light is when it is traveling from denser medium to rarer medium, how the depth of the object is going to change. So that we discussed the lateral shift, apparent shift, as well as even we discussed some of the concepts which comes under the total internal reflection, that is said to be the critical angle and all. Right. Now, my part is to move towards the discussion of derivation of refractive index of the prism. So, my dear students, to derive the expression for the refractive index of the prism, first we should know what is a prism. First we should know what is prism. Yes. Dear students, you might have observed the prism even in your 10th class, right? I am just going to write a prism. So, whereas if I just write a prism, it is like a rectangle. So, it is like a triangle, my dear students. If I just represent that as a face A, B and C. So here you can observe this is a planar picture that what I drawn here, but I have not represented in case of AB. So if I just shown you in case of a three-dimensional view, so you can observe that this prism is a one, it is an optical medium. So prism is an optical medium. Prism is an optical medium. Prism is an optical medium with two triangular faces. With two triangular faces and three rectangular faces. Three rectangular faces. So we have three rectangular faces as well as two triangular faces. When we come towards this prism, these three rectangular faces are all not the refracting faces. In these three rectangular faces, only two faces are considered as refracting faces. Two faces are considered as the refracting faces, and the remaining one face is considered as the base, where base is not going to refract the incident beam of light. As well as this base is the one which is completely made rough, so that it is not going to refract any incident beam of light. See, just even I can write the prism in this way. Why I am going to call this prism as an optical medium? Because it is going to show some of the optical phenomena of light. Now, I am just going to show the figure in this way, so that to make you understand clearly, so that I am just going to write it in this way. So whereas this is said to be the prism, whereas here we have another one triangular face, opposite to this triangular face we have another one triangular face here, whereas you can even see it in this way. You can observe that. So here we have, this is one rectangular face. Here back side to this we have another one rectangular face. Base is said to be another one rectangular face. Finally we have three rectangular faces, and this is one triangular face, and this is the second triangular face. Whereas this base is rough and it is not used for the refraction purpose. Whereas the face which is present here and opposite to this, both two are called as the two rectangular faces. Whereas these two rectangular faces are very much essential for the refraction purpose. The refraction is very much clear in case of these two refracting faces. And even you can observe that the section of this prism, so that you can observe the section of a prism. So whereas this section by the name A, B, C, which was present here, it is called as a principal section of the prism. As well as, my dear students, the edges that you are observing here, These edges are called as refracting edges. These edges are called as refracting edges. So this is about the prism, whereas the prism is used in the preparation of binoculars. Even the prism is used in the preparation of telescopes and all. So for the preparation of the binocular, we need the prism, right? Then how to calculate this refractive index? So to calculate the refractive index of a prism, I am just going to derive an expression. So now let us move towards the derivation of expression for refractive index of a prism. Derivation of expression for refractive index is represented by a symbol capital R, capital I. Refractive index of prism. Right. Yes, this was my main intention. So now to derive this expression, I am going to consider that the prism is under minimum deviation condition. So I will explain you what is the minimum deviation while just explaining you this, right? So I am just going to write a diagram here now. So whereas this is said to be the prism, let us name this prism as A, B. See, I am going to name this prism as A, B, C. Now, whereas this is said to be the angle of the prism, represent the angle of prism as A. In this, BC is considered as the base. So whereas we have the refracting edges AB and AC. I am going to incident array of light. See, whereas I am going to incident array of light. Let us give the name. PQ is the incident ray. Right? Now, at this point, I am going to draw this normal. I am going to draw the normal at the point of incidence. Let us name that normal as N. The angle which was present between the normal and the incident ray is called as angle of incidence, represented by I1. See, after when the ray of light travels from one medium to another medium, it undergoes refraction. Exactly, now the ray of light is traveling from air medium to glass medium. It means the ray of light is traveling from rarer medium to denser medium. So it bends towards the normal. Yes, it bends towards the normal. Whereas the angle which was present between the refracted ray and the normal is considered as the angle of diffraction, represented by the symbol small r1. Dear students, whereas here I just written another one ray, that is QR, which is said to be the refracted ray, refracted by the first refracting surface, that is AB. So here, after refraction, QR ray is going to fall on another refracting phase, that is AC. When this refracted ray falls on another refracting surface said to be AC, so then here it again undergoes a refraction because AC is a refracting phase. Now, at this point of incidence, I am going to draw the normal again, whereas this normal is again considered as N. Dear students, now the ray of light is traveling from denser medium to rarer medium. So it bends away from the normal. It bends away from the normal. Whereas I am going to call this RS as a emergent ray. Now, see, whereas this angle is called the angle of incidence for the second refracting surface. I am going to represent it by R2. Similarly, the angle of refraction for the second phase is considered as I2. Right? So I2. Right. Now, whereas I1 and R1 is the incidence and the angle of refraction for the first phase, and R2 and I2 are the angle of incidence and the angle of refraction for the second phase. So to understand this clearly, see my dear students, actually this is the direction. I am just going to extend this direction of incident ray. This is the direction of incident ray. If the prism is absent, if the two refracting surfaces are exactly absent, then this ray of light might have traveled in this direction without undergoing deviation. But due to the presence of first surface, it is deviated through this angle. So this is called as angle of deviation for the first surface, represented by D1. Similarly, for the second surface, if the second surface is absent, the ray of light might have traveled in this direction. But due to the presence of second surface, this light ray has deviated with an angle of deviation said to be D2. See, here I just shown you the angle of deviation D1 and D2 by just considering two different refracting phases, that is AB and AC. Even we can write the total deviation which was produced by this prism. How to write the total deviation? See, my dear students. So here the ray of light said to be PQ is going to travel in the same direction. Suppose if the prism is absent. But due to the presence of a prism, so it has been deviated to this direction, so that this angle of deviation is represented by the symbol capital D. That is the total deviation produced by the prism, which is equal to the sum of the two deviations which was produced by the prism at the first refracting surface AB and the second refracting surface AC. Right? I am going to write all the things. So whereas PQ is the incident ray, I am going to represent here PQ is said to be the incident ray. So all such things. So your PQ is said to be the incident ray, whereas QR is said to be the refracted ray, and RS is said to be the emergent ray. Yes. And you can observe that we have some angles I1, R1, D1, R2, I2 and D2. So let us write all those things. Whereas I1 and R1, right? I1 is an angle of incidence. It is an angle of incidence at refracting surface. Simply I am writing it as RS. Don't write it as RS. At the refracting surface AB. That is simply at the refracting surface AB. Similarly, the other is angle of refraction at refracting surface AB. Then similarly, D1 is the angle of deviation. D1 is the angle of deviation at the refracting surface AB. Similarly, we have R2, I2 and D2. Let us write it. So what is I2? I2, R2 and D2. I2 is the angle of, it is an angle of incidence at refracting surface. Which refracting surface it is? AC. And similarly, R2 is the angle of refraction at the refracting surface AC, and angle D2 is the angle of deviation at the refracting surface AC. This is how we represented that the values. The points are actually that whatever we written over here, as well as where A is said to be the angle of the prism and capital D is the total deviation produced by the prism. Now let us move on for the derivation of refractive index. And one thing you remember, that is ABC is called as the principal section of the prism. Yes. Now let us consider from Snell's law. I am just going to use the Snell's law. By using Snell's law, what exactly the Snell's law states? Snell's law states that the sign of ratio of sign of angle of incidence to the sign of angle of refraction is always equal to the constant called as refractive index. So I am just applying the Snell's law for the first refracting surface, that is AB. So then here the refractive index n can be written as sin I1 divided by sin R1. So take it as equation number 1. You can observe that in the question, in that formula, n is said to be the refractive index, I1 is said to be the angle of incidence at the first refracting surface, and R1 is the angle of refraction at the first refracting surface. Then my dear students, now I want to calculate I1 and R1 first. So to calculate I1 and R1, we have that the total deviation D can be written as the sum of the deviation produced by the first refracting surface and the deviation produced by the second refracting surface. So that let us use this formula. So from figure, so you can observe that D can be written as D1 plus D2, or that is what the total deviation D can be written as D1 plus D2. Just I am writing as capital D itself, just can be written as D1 plus D2. Then how to write D1 and how to write D2. Hope you know, my dear students, while I am discussing that the derivation, or that is what how to write the deviation formula in case of the ray of light which was traveling from rarer to denser medium, as well as when it is traveling from denser to rarer medium. So while discussing that case, while discussing that refraction, I said you, my dear students, that the angle of incidence is always greater than the angle of refraction in case of the light traveling from rarer to denser, and when the ray of light is traveling from denser to rarer, angle of refraction is greater than the angle of incidence. Then the angle of deviation D can be written as I minus R, and the angle of deviation D can be written as R minus I. This is what I discussed in the previous class. Now apply the same thing over here. I am going to apply it for the first refracting surface, as well as I am going to apply the same thing for the second refracting surface. Let us observe it carefully. Here I am using the first refracting surface. For the first refracting surface, angle of deviation is D1, right? So here the ray of light is traveling from rarer medium to denser medium. So when a ray of light travels from rarer to denser medium, this angle I1 is greater than R1. I1 is greater than R1. So that angle of deviation D1 can be written as I1 minus R1. Similarly, let us see this case. Here we have the angle of deviation said to be D2. So this is for the second refracting surface, that is AC. Dear students, in this case, that for the second refracting surface AC, I am just going to show you that here we have the angle of incidence R2 and the angle of refraction I2. Don't confuse with this representation. Angle of incidence is R2 here and the angle of refraction is I2. As well as the ray of light is traveling from denser medium to rarer medium. When the ray of light travels from denser medium to rarer medium, so you know that this I2 is actually the angle of refraction here. So that I2 is greater than R2. I2 is greater than R2. Please be careful. This is the angle of incidence I. This is the angle of refraction R. The ray of light is traveling from denser to rarer. It means R is greater than I. So dear students, what happens now? So for this reason, I2 minus R2. I want to write it as I2 minus R2. Finally, we got the values of D1 and D2. D1 is written as I1 minus R1 and D2 can be written as I2 minus R2. So now D becomes equal to, so what is D1 as we did here, which is I1 minus R1, and here it is I2 minus R2. So I1 minus R1 plus I D2 is I2 minus R2. Yes. Now let us take the items towards one side and items towards another side. So D can be written as I1 plus I2, close the bracket, minus of, here it is R1 and the remaining is R2. So that minus of R1 plus R2. Take it as equation number 2. Still we have to do the lot of things to just derive the expression for the refractive index of a prism. carefully that we just written so many rays so that we got A, Q, N, R. A, Q, N, R as a quadrilateral. So I am just going to write from the quadrilateral. From the quadrilateral, yes, that is what? A, Q, N, R. Observe it carefully. A, Q, N, R is going to be the quadrilateral. In quadrilateral, the sum of two opposite angles is always equal to 190 degree. So angle A plus angle N can be written as equal to angle A plus angle N is equal to 180 degree. Angle A plus angle N is equal to 180 degree. Now take it as equation number 3. Similarly, we have another one triangle here, that is Q, N, R said to be the equilateral triangle. We have Q, N, R as a triangle that is said to be equilateral triangle. So I am just writing that from equilateral triangle. From triangle QNR, you know that from mathematics, that is for equilateral triangle, sum of all the angles is equal to 180 degree, that is R1 plus R2 plus N is equal to 180 degree. Take it as equation number 4. You can observe that the equation 3 and the equation 4, in place of A, we have R1 and R2, right? So now equating or comparing equation 3 and 4, what will get? So in place of A, we have R1 plus R2. So that A is equal to R1 plus R2. So my dear students, we got that the angle of prism A is equal to the sum of the two angles R1 and R2. Then we came to know that D is equal to I1 plus I2 minus of R1 plus R2 is present here. So then in place of R1 plus R2, I can simply write it as A. So then put equation 5 in equation 2. What will get now? See here. So D is equal to I1 plus I2 minus of A. In place of R1 plus R2, I just written it as A. So simply you can write it as A. Here it is A. I1 plus I2 minus A. Okay. Angle of deviation is I1 plus I2 minus A we got. So now take this one as equation number 6. Take this one as equation number 6. So dear students, we just got that A and D. Now with the help of A and D, we should calculate the value of I1 and R1. So how to calculate this, my dear students? Assume that this prism is in minimum deviation condition. I will explain you what is minimum deviation, but assume that now the prism is in minimum deviation condition.
Madam, stop.
As I said you that the prism is in a minimum deviation condition. When the prism is in minimum deviation condition, this angle of incidence and the angle of emergence both are same. And my dear students, as well as the angle of refraction and the angle of incidence for the second refractive phase both are same. Please be careful, I am repeating again. This is angle of incidence, this is angle of emergence for the entire prism. So that what happens now, my dear students? I1 is equal to I2 and R1 is equal to R2. So that is what in minimum deviation condition, I1 is equal to I2 and R1 is equal to R2. What happens to the equation 5 and 6 now? Then therefore equation 5 implies that A is equal to R1 plus R1, it means 2R1. Therefore R1 can be written as A by 2 take it as equation number 7. So I got R1 is equal to A by 2. Then now let us continue this. I am just going to substitute this in equation number 6. So the equation 6 becomes equal to D is equal to I1 plus I1 minus A. I1 plus I1 becomes 2I1 minus A. So now I want to calculate I1. Place I1 as it is, which becomes A plus D. So I1 is equal to A plus D divided by 2. Take it as equation number 8. Now my dear students, our job is almost all completed. That we calculated the value of I1 and also we calculated the value of I1 and R1. So now let us substitute the I1 and R1 in equation number 1. So substitute I1 and R1 in equation 1. Let us see what will happen. N is equal to sine of, what is I1? I1 is said to be A plus D divided by 2 all divided by, what is R1? Sine of A divided by 2. Sine of A divided by 2. Okay dear students, finally we just derive the expression for the refractive index of a prism which is under minimum deviation condition. So that the refractive index N is equal to sine of A plus D by 2 and divided by sine of A by 2, where there is a refractive index, A is the angle of the prism and D is the minimum deviation produced by the prism. So this is about the derivation of expression for the refractive index of the prism. Hope you all got this, my dear students. Now let us move towards the plotting of the graph here. So now we can plot a graph for this prism, so that by taking angle of incidence along x-axis and angle of deviation along y-axis. Yes. Now I'm just going to plot a graph. So you can observe here. So along x-axis I'm going to consider angle of incidence, and along y-axis I am going to consider angle of deviation. See my dear students, the graph will be in this way. The graph will be in this way. Whereas you can observe that the angle of deviation is more while angle of incidence is less. As you are increasing the angle of incidence, the angle of deviation decreases. At some point, the angle of incidence becomes equal to the angle of emergence. So because I1 is the angle of incidence, I2 is the angle of emergence. So at this position, this is the position when the angle of incidence becomes equal to angle of emergence. That position is called as minimum deviation position. That position is called as minimum deviation position. Suppose if in case, even if you increase the angle of incidence, so then what happens? The deviation increases. So at some point, the angle of incidence becomes equal to angle of emergence. That is said to be the point of minimum deviation position produced by the prism. This is about the refractive index of the prism. So then, my dear students, this prism even it produces effect of dispersion, and also this prism is used in the preparation of binoculars. Now let us move towards the discussion of thin prism, and also let us see the formula for the thin prism, deviation formula for thin prism. Hope you all know that the prism is an optical medium. Why? Because the prism is the one which is going to show you the optical phenomena, as well as it is the one which is going to produce a spectrum where the white light is going to incident on the prism. Now I am moving towards the discussion of thin prism. What is this thin prism? It is simply a prism. It is simply an optical medium and which is having very small angle of the prism. The prism with a small angle, that is said to be the thin prism. It means the angle of the prism is very small. That kind of prism is said to be the thin prism. So if the angle of the prism is very small, so then what happens here, if the angle is very small, then the deviation produced is also becomes very small. By the time there is no need to consider the values of sin I, sin r. So even we can write simply that the sin I is equal to I itself, and even we can simply write that the value of sin r is nearly equal to r itself. So my dear students, so I am just moving towards the calculation here. The refractive index of the prism. We know that the refractive index of a prism n can be written as sin of a plus d divided by 2 or divided by sin of a divided by 2. So as I said you before that the small angle prism is said to be the thin prism, so that we can write that the sin theta is nearly equal to theta. It means sin of a plus d divided by 2 is nearly equal to a plus d divided by 2, or even we can write sin of a by 2 is nearly equal to a by 2, right? So that here in this case I am going to do the same idea, students. So that the refractive index n can be written as sin of a plus d by 2 can be simply written as a plus d divided by 2 divided by a by 2. So now you can observe that 2 cancel with each other. Then the refractive index is left with a plus d divided by a. Now I just want to take out the equation for d. For this reason I am moving out writing here. So n is equal to a plus d by a can be written as a divided by a plus d divided by a, right? So a by a is equal to 1 because a by a is always equal to 1 plus d divided by a. Now I am going to shift n towards this side. So what happens now? D by a becomes equal to n minus 1. I want to know the formula for the minimum deviation of this thin prism, so that the minimum deviation of the thin prism Dm can be written as n minus 1 into just doing the cross multiplication, it becomes n minus 1 into a. Yes. So this is the final expression for the minimum deviation produced by the thin prism. So that the formula can be written as n minus 1 into a, whereas n is the refractive index of a prism and as well as a is said to be the angle of the prism. So this is about the refraction which was produced by the prism, dear students. Now let us move towards the discussion of the applications of total internal reflection. Actually, before discussing this refraction itself, I should discuss that the applications of the total internal reflection issues. Now let us see what are the applications which comes under this total internal reflection. Applications of total internal reflection. Yes, dear students, when we come towards the applications of total internal reflection, we can see n number of applications. That is what mirage is one of the best natural example. Not only the mirage, when you come towards the discussion of the sparkling or the brilliance of a diamond. So brilliance of a diamond is also one of the application of total internal reflection. So brilliance of a diamond becomes a very best example. And with this brilliance of a total, the brilliance of a diamond, so even you can move towards total internal reflecting prisms. These are also one of the best applications for total internal reflection. Whereas another one is that, so that is said to be optical fiber. So that the optical fiber is used in telecommunication nowadays. You are very much familiar with the transferring of audio and the video signals with the help of optical fiber. So with this, even I can use the mirage as one of the example to explain the total internal reflection. But in case of your examination, exactly they may ask you to write the applications which is related to the optical fiber as well as related to the total reflecting prisms. So that in case of the total reflecting prisms, let us discuss how actually the total reflecting prisms are going to form you the diagrams, or they are going to reflect and how they are going to form the image. So now let us see the brilliance of a diamond, so that you know that diamond is a one which is having a refractive index of 2.42. See, I am just writing the refractive index of a diamond now. So dear students, refractive index of a diamond is 2.42. So whereas the refractive index is what? Still more. When we come towards the critical angle, because for the phenomenon of total internal reflection, we should know the value of that is said to be the critical angle. So that the critical angle for the diamond. Critical angle for the diamond is said to be 24.2, right? Critical angle is 24.2. That is what if a ray of light which is going to incident on the diamond, because you know that diamond is having a lot of cuts, so that those cuttings are exactly prepared in such a way that the ray of light which is going to incident is exactly undergoing the total internal reflection. That's why the diamond is going to show the sparkling effect, as well as that's why the diamond is going to show the brilliance effect. But the angle of incidence for the diamond should be always greater than that of the critical angle. That is what the angle of incidence should be greater than that of 24.2 degree. Then only we can observe the total internal reflection. So that due to this reason, the diamond is going to sparkle. And one thing is that suppose if any light ray enters into the diamond which is less than this critical angle, those light rays going to emerge out without undergoing the total internal reflection. Okay, dear students, this is all about the class that we discussed today. Hope you all just gone through the concept that what I discussed now. And the next class I am just going to continue with the applications of total internal reflection. Thank you.